CPUs, GPUs, TPUs, NPUs, and VPUs. What does it all mean, and what do you need to know about it? G'day. Well, we all know about AI or artificial intelligence, but what's spawned this great surge of interest is largely driven by the application-specific integrated circuits, or ASICs. This has really got to the point now where we have so much processing power that we can do things that were impossible only a few years ago. And the core of this is things like CPUs, GPUs, VPUs, and NPUs. All of these make up computer systems part of an artificial intelligence system. So let's get into it. CPUs, or central processing units, are common in all computers. In fact, the first computers that I had back in the 80s had a central processing unit, and they're still available today. Of course, what's changed over that time is the power of the central processing unit. So a central processing unit is a general workhorse of a computer. You can run an operating system on there. It has a bunch of memory, which is generally called low-speed memory. It can do a lot of the capable things to run a computer. You run your programs on there. It's a general workhorse central processing unit. What drives the capability of a central processing unit is the speed that it can run at, its clock speed, and the number of parallel processing cores that you can run. And often CPUs have multiple cores and multiple threads. But in a simple sense, it's the speed of the clock which drives the speed of a central processing unit, CPU. Back in the 80s, computers that I had access to had clock speeds of around 4 megahertz. Now we have clock speeds up into the gigahertz, so it's thousands of times faster than it was back then, giving it a lot more capability. But capability runs out with CPUs when you start doing specialized tasks. There are many applications that require not general use but dedicated use, such as running mathematics to render gaming onto a screen, and the mathematics needs to be done in a very similar way many times, and in that case we need something more application specific, an application specific integrated circuit, or ASIC, of which the next class of computer chips I'm going to talk about, and they're going to be GPUs, NPUs, TPUs, VPUs. These are all application-specific integrated circuits. So different to CPUs, which are general, they run a workhorse, a multitude of things. We have dedicated chips which run very high speed, and many gamers are very familiar with having a good graphics card or a graphics chip in their computer. GPUs, graphics processing units, are used extensively in gaming, and it's quite common for gamers that do this for fun and even professionally would use very powerful GPUs. GPUs essentially take the programming output of the program and render it onto the screen, making a simple graphics into something that's lifelike. And that is done by creating tiny little triangles of the image. And some images might have 10 million triangles, and we're trying to run a high speed at 60 frames per second. So you can imagine the calculations required to do that. And this is where a graphics processing unit has the capability to do that. They run essentially a matrix, a 2D matrix, so X and Y, and do a lot of mathematics on those matrices to create the renders. So GPUs are very powerful. They often have high speed access to memory, fans to keep them cool, and they're very powerful for rendering games and gaming applications. NPUs, or neural processing units, is the next major class, and within that are VPUs and TPUs, we'll talk about in a second. NPUs, or neural processing units, effectively have a bunch of neurons, like what is in the human brain, connected in a large network. So the model or the architecture within the chip is similar to that for the human brain. Where this has great application is in artificial intelligence applications, where instead of writing a program on inputs and give outputs, we train the model on data, given the outputs, then when we have new data, we can predict the outputs. And it's this learning methodology which creates this need for a neural network architecture. It's particularly good for things like facial recognition and for video processing work, where we have very, very similar requirements and similar mathematics running. And again, it's back to this specialization. When we need an artificial intelligence model to run, a neural network is a great network to do that. Now, what are the differences between a neural network and a GPU? Well, neural networks typically are more specific to artificial intelligence, and they run on lower power applications. So we're starting to see these NPUs appear within chips that go inside cell phones for facial recognition, or controlling the cameras, or for video processing work. And all of this is happening in real time for the user in a very low power application. The way we measure the performance of NPUs is in tera floating point operations per second, or TFLOPS. In the Hawkeye product, it runs at 1.2 teraflops, so it's 1.2 trillion floating point operations per second, and that is enormous compared to a CPU. So its dedicated hardware is able to do an enormous amount of processing because it's doing a lot of this in parallel, compared to a CPU, which does things more in serial. I know there's of course parallel paths and threads and that. There still is an enormous benefit you get from running an NPU when you need to do a lot of calculations. Now, that's by no means the fastest NPUs, and at the time of this video being created, we're seeing NPUs at 30 teraflops, so much, much higher performance than the Hawkeye product. And then there are dedicated chips which are being developed in-house within certain companies where those measurements known to us. TPUs, Tensor Processing Units. These are proprietary ASICs built within Google, and TPU is a term that comes from Google. They're not available to us here in the industry, and they essentially are like a GPU which works on a 2D matrix, but using a tensor architecture, which means they have multiple matrices, so not just 2 by 2 but 2 by 3 and all the way up to n. And it's the tensor which is the mathematical way of describing more than 2D matrix. If you have any understanding of general relativity, then you know that tensors is the mathematical foundation for calculating that. So TPUs is Tensor Processing Units, and it's proprietary to Google. The last ASIC I want to talk about is the VPU, or Video Processing Unit. Now, in Hawkeye, the neural network here is actually classified as a video processing unit. It can actually take multiple camera streams in, and it is dedicated to processing the video and generating metadata from what it detects from the cameras. So the structure of that particular NPU is dedicated to video processing, and hence the term a VPU, or Video Processing Unit. So to summarize, CPUs, Central Processing Unit, generalized operating system, is pretty much embedded with any computer system. GPUs is for graphics, for rendering high-speed video in a 2D form, like for displaying graphics in a high-speed game. And then the other class is NPUs, or Neural Processing Units, of which there's two classes, which are TPUs and VPUs within that. I hope that helps, and if you have any questions, please leave them in the description below. We definitely read all of our questions, and we'd like to respond to those with some new videos. If you like the channel, please hit the like button, subscribe, and turn on all notifications. And I hope that helped, and thanks for watching.